We're moving on up to 5.3, which is adding, subtracting, and multiplying radicals. Our objective today is that students will be able to add and subtract like radicals and multiply radical expressions. So like radicals are just like terms where you combine like terms based on if they have the same exponents. Like radicals are radicals that have the same root number, whether it's a square root, cube root, fourth root, whatever the root number is, and radicand, which is expression under the root. So an example is the square root of x and y and 5 square root of x and y. Those are like radicals. Or negative 2 to the cube root of 4ab and 7 cube root to 4ab. What's under the radical are the same thing. You can see under this radical is cube root of 4ab, cube root of 4ab. Here it was square root of xy, square root of xy. So those are my like terms. Now, really quick, I put screenshots on your paper on how to enter radical on a TI Nspire. Use the button that's next to the number 9, which is highlighted here in red, and it will give you what is shown in the right. You choose as necessary. So the third one, which is right here, that's my square root of some number, and then the other one is when I want to enter like the cube root or whatever the case may be. Any number can go here. Alright, so the number that's next to the 9, and it's highlighted on this. So the first thing we're going to look at is adding and subtracting radical expression. The first thing you always want to do is simplify the radical, which goes back to 5.2. And then step 2, we're going to combine like radicals. You can only add or subtract radicals together if they are like, okay? Remember that. Only if they add or subtract if they're like. So the rules are, if you have a radical b plus c radical b, I am just going to be adding the a and the c, and whatever is under my radical stays the same. And it's the opposite for addition. So instead of me adding a and c, what I'm doing now is subtracting. And again, what's under my radical sign has to be the c. Let's see how some example works. Example 1 says 2 radical 20x plus 3 radical 5x. We see what's under the radical is not the same. So step 1 says to always simplify. So 20 I know can be simplified, where I'll write 2 radical 4 times radical 5x plus 3 radical 5x. How do I know it's this? So the hint is that 5x is what I'm looking for. I want to take something out of this 20x to make it 5x so that I can simplify. This I know becomes 2 times 2, because the square root of 4 is 2. Radical 5x plus 3 radical 5x. 2 times 2 I know is 4 radical 5x plus 3 radical 5x. Now it looks like something like this. So all I'm going to do is combine my 4 and 3, which is 7, and then what's under my radical sign, the 5x, stays the same. And that's it. Super easy. Let's look at another one. We see that it's negative 7 square root of 11 minus 4 square root of 44. Now we know it has to be the square root of 11 cannot be broken down because that's prime, so we know that we have to break down this 44. So let's do that first. So negative 7 square root of 11 stays the same, minus 4 times square root of 11 times 4. And again, I know it's 11 because that's what I wanted. Negative 7 square root of 11 minus 4. The square root of 4 is 2 radical 11. This becomes 4 times 2 is 8, my radical 11. So negative 7 minus 8, which is something that looks like our subtraction up here, becomes negative 15 radical 11. That's my final answer. Alrighty. Now moving on ahead, we have example 3. Now this one looks like a lot. So square root of 20 plus square root of 44 minus square root of 45. So I need to break all of these down because I know it's not in simplest form. I know 20 is 4 times 5 plus 44, which we did up here, is actually 4 times 11 minus, and then 45 is 9 times 5. And again, if you don't know how to do this, remember what we talked about in 5.2. Write these numbers down: 0, 1, 4, 9, where are we? 2, 3, 4, 16, 25, 36, 49, and look for factors. These are my perfect square. Now this becomes 2 radical 5 plus 2 radical 11 minus 3 radical 5. And again, with this, I will also, because it's addition and subtraction, I have to make sure I use PEMDAS. I do addition and subtraction, whichever come first, from left to right. Now, the last thing that we need to remember is I can only do addition. Remember what we said in up here. I can only add or subtract radicals together if they're like radicals. So we see like radicals are 2 radical 5 and minus 3 radical 5. So 2 minus 3, I know it's negative 1 square root of 5 plus 2 radical 11. I could not have combined the 2 radical 11 because they had nothing in common. So this is my final answer. This 11 could not be broken down into something that had a 5. Remember, I can only combine like radicals. Now I'm going to take this off so I can get some space to do number 4, which is a little bit more complex. So number 4, and let's move these here over just a little bit. Move these down over for me. Perfect. So with this one now, we're dealing with cube roots. So anything that has a number here, this is known as a cube root. When you see something like this, we call this square root. There is that invisible 2 here, which we don't write because it's implied. Now I want to break these down. Cube root, and I want to be very clear on this. Cube root is when I multiply 3 numbers. So let's say 2 times 2 times 2, this is 8. This is the same thing as saying 2 to the third power. That's a cube root. So I want to break these down here and step by step. So draw this line over here so we don't get mixed up. This is something totally different. Good. So we have the cube root of 3, and then we have the cube root of b cubed minus 3b, and I want to break this down. I know I'm going to have a 3, so 3 times the cube root again of 8. So all I'm doing is breaking these down. Notice here is the 3, that's what I'm looking for. So I say 24 divided by 3 is 8, and I give it back my cube roots. Plus 2, I know it's going to be the cube root of 3, and then the cube root of 27. Oops, that's a 27. That's a 7. And then I also have the cube root of b cubed. So again, what did I do? I noticed that I had to get a cube root of 3, so I want to make sure they all have the like terms. So how do you do this? On the calculator, remember we said you just go to the number next to 9 and you would choose the 4th option where you can enter the 3 in there. So the cube root of 3 stays the same, and then b cubed to the cube root is actually b, which is just like me saying the cube root of 8 is 2, because 2 times 2 times 2 will give me 8. This remains as 3b, and oh, look at this, cube root of 8, we just said it was 2, and then this stays at the cube root of 3 plus 2, We're going to keep the cube root of 3 at the end. The cube root of 27 is 3. 3 times 3 is 9. 9 times 3 is 27, or just enter that on the calculator. And then the cube root of b cubed is b. So let's go ahead and simplify this now even further. This is b cube root of 3 minus 3 times 2 is 6b cube root of 3 plus 6b cube root of 3. And again, we have addition and subtraction, and PEMDAS says we do addition or subtraction, whichever comes first from left to right. So b minus 6b is going to be minus 5b cube root of 3. I can combine them because they all have the same, and we can highlight that just to make they all have the same or the like radicals. So we already combined this plus 6b cube root of 3. Now this I can also combine. What is minus 5 plus minus 5b plus 6b? That would give me a positive b to the cube root. And this was my final answer. Now you can breathe. I know that seems like a long one. You can pause it, rewind it, and take a look back at this question. The last thing that we want to talk about today is how do we multiply radical expressions? So multiplying radical expression is two things again. We multiply the radical expression and then we simplify. So just some really quick recap. Multiplication of radicals simplify requires that we multiply the variable under the radical sign. So if I had something as square root of a times square root of b, it would just multiply my a and b. Remember, when multiplying exponents, the base must be the same, then we just add the exponents. So a to the m means that you have factors of m times, and you're adding n more factors. Remember this rule, a to the m times a to the n, we just add the exponents. Last thing is our product of conjugate. You see this now over and over and over, which we talked about as the difference of square. Now this is going to come useful, especially in our next unit where we're going to be rationalizing denominator. That was a question on your finals. So we have an expression 4 plus radical 7. The conjugate, remember, it's the opposite, so it's 4 minus 7. When we multiply them, all we're doing is squaring each of my a and my b. So in this case, my a, in the first case, my a is equal to 4, and my b is equal to radical 7. And then this becomes 4 squared, which is 16, minus, and remember, difference of square is a squared minus b squared. It's going to be a plus b and a minus b. Hopefully you remember the difference of square. And then radical 7 squared is 7, which will give us 9. Now what if we had letters and variables involved? Square root of 3 minus c. My conjugate is square root of 3 plus c. Now square these, I will get 3 minus c squared. That's it. Now let's look at some examples. The first example says that we use the product rule. So notice all I'm going to do is multiply what's underneath. So it's a cube root of 3 times 2, which is the cube root of 6. That's it. That's it, nothing else. Now look at this. Use the product rule to multiply again. It's the same root, the fourth root of 2 times 5 is 10. X squared times x, remember the rules say we add the exponent, x to the third, that invisible 1 up there. Y times invisible 1s. Y times y is y squared. That's it. Now these are a little different where I'm using this is my distributive property. So this is the distributive property. So we have square root of 2 times square root of 3 minus square root of 2 times square root of 8. This becomes, what do we say, 2 times 3 minus 2 times 8. That's our definition. This becomes square root of 6 minus square root of 16. We know that square root of 16 is actually 4, and that makes it my final answer. Our last our last example says multiply and simplify. So we can use the box method or we can do FOIL. Some of you like FOIL. So I like the box method, but it doesn't really matter. Just like you would do multiplying binomials, we're going to do the same thing here. This becomes the square root of a minus 5. It doesn't matter where I put what, square root of a, 3 square root of a, and then this is plus 7. Let's fill this in. That's square root of a. It looks like a 9. Let's fix this. I thought it was a 9 too. So this is an a. Alrighty, so this becomes 3 square root of a times a, which is a square. This becomes 5 times 3, negative 15 square root of a. This becomes 7 square root of a, and this minus 35. So what we want to do is combine my like terms, and we will get 3 square root of a square, a times a, remember you multiply what's under, minus, what's minus 15 plus 7 is minus 8 square root of a minus 35. Now this can even simplify, that's why it says to simplify. The square root of a squared is actually a, so this becomes 3a minus 8 square root of a minus 35, and this is my final answer. Nothing can be simplified, nothing can be combined. You just have to remember when you're multiplying this, remember I take what's under my radical. A times a is a squared, that's where this is coming from, and remember these two kind of cancels off each other. So 3 times a is 3a. And that's it for adding, subtracting, and multiplying radicals. See ya!